This live Slooh show is brought to you by the support of Slooh members and the following sponsors. Visit slooh.com to become a member today. Hi, this is Slooh, and I'm Bob Berman here to bring you the eclipse of the sun. Yes, an eclipse of the sun. That's a lineup. That's an alignment. That's kind of the cool stuff that people have been celebrating since time began. I mean, we'll talk about some of the cultural significance as we look at this graphic that shows the moon's shadow as it's passing across the Earth's face. That's going to begin in just a few minutes from now. Look at this. Let's study this. We see on the left side of this animation the dark side of Earth, the night side of Earth, where many of us in North America are experiencing, all of us actually. And then on the right side, the place where it's daylight. Of course, an eclipse of the sun can only be seen in daylight because if the sun isn't in your sky, how it can it go into eclipse? Notice that down at the bottom, Antarctica, the shadow of the moon sweeps over half of Antarctica. So that's going to be like ground zero for this eclipse. Also, look at the southernmost tip of Africa at about the 1 o'clock position, if this were a giant clock that you're looking at, and you'll see that the moon shadow also sweeps over that. This is a very, very cool animation because it really shows you. This is from NASA, and this shows you exactly what's going to happen. It begins just a few minutes from now. So while we do this over the next several hours, because that's how long it lasts, we'll bring you interviews with solar experts and all sorts of other cool stuff. We'll talk about aspects of the lineup of the Earth and the Sun and the Moon, which is also going to cough up another spectacular event, one that will be visible throughout the United States just 2 weeks from now when the moon in its orbit goes to the other side of its orbit and goes into Earth's shadow. It all depends on there being a straight line in space. Now, if you were drawing this on a chalkboard, you might think that you're going to get a line up at every full moon and every new moon. It looks like if you just draw circles around the Earth, the way we're showing here, that the moon is going to go into Earth shadow. And now we'll stop it for a moment. There is the moon and Earth to scale. This is really cool. The moon is actually 30 Earth diameters away, much farther than most of us visualize. Now, on most months or new moon cycles, it misses us. But if the plane of the moon's orbit is aligned enough, it'll hit us. And that's what's happening today. So the moon shadow reaching Earth is what produces a blockage of the sun, solar eclipse. We're seeing it right here. And look in the third dimension, most months, you see how the moon shadow goes under the Earth? It doesn't hit it. But some months, just when it's a new moon, it's going to hit the Earth. So that's what happens. The two shades of blue, top and bottom, are where that plane is, where the tilted orbit of the moon happens to point towards the sun. So, or in other words, when the moon can reach a three-dimensional alignment with the sun and the Earth. Again, look at this. You see how the moon shadow misses Earth, passes below it in a sideways view. But on this one, the moon shadow hits us. So it all depends upon what part of its orbit it's on. And that dark and lighter blue shows that the moon has to reach somewhat near that crossing point or node when it goes from below the plane to above or above the plane to below. And those crossing points occur at opposite sides of the moon's orbit around Earth. And that's why the moon reaches opposite sides when it goes from new moon to full moon or full moon to new moon. Bottom line to all this crazy stuff, it's so complex that even Isaac Newton long ago said that just thinking about the moon gave him a headache. But you can see that once you understand how these nodes, look how the moon here is hitting uh, the new moon uh, period not when it's crossing the node, and therefore the shadow doesn't reach us. Whereas if it hits us uh, very close to a node, the shadow will indeed reach us. So it's a matter of three dimensionality, whether we have a lineup, a true lineup in all three dimensions, or just looks like that in two dimensions. So if you look straight down on the moon and the Earth orbit in two dimensions, look, it looks like the moon shadow is reaching Earth, right? But tilted on the side, and you can see the moon shadow really misses Earth. So you need the alignment to be perfect in all three dimensions, and that's what's occurring. There is the sun now. This is a live view from one of our feed partners, Paul Funk. We're looking at it from South Africa. The sun is just rising, and the moon is getting very close to it. Now we're only about 3.5 minutes away from the moon starting to touch the sun's limb. Wow, this is so cool. In other words, we're bringing you this live. This is a live eclipse. You know, we're not fooling around with like a photograph that they're going to fax us or send us by email and then we're going to show to you. We're going to see the thing as it's happening in real time. Early in the morning, it's wintertime there, often a cloudy time of year, so we got lucky with the weather. And there is the sun. So we're going to zoom in a little bit and actually be able to see the eclipse once it begins. And once it does, here's what happens. It takes about an hour for the moon to cover up the sun. Now, the alignment isn't so perfect that we're going to get a total solar eclipse. Whenever we do that, we send people, we send a whole team here at Slooh to cover those. And 2 years from now, on August 21st, 2017, we're going to have our first total solar eclipse in the United States, a coast to coast totality. The first eclipse in mainland America in 38 years. Whoa, that's going to be amazing. So until then, we'll have mostly partial eclipses. And they're interesting in their own way. Here's a countdown clock. You see it at the top of your screen, counting down to when the moon will start touching the edge of the sun. So we've got about an hour of the moon intruding upon the sun. Then we reach the maximum eclipse, which in this case, this particular eclipse will be 79% of the sun will be covered, which will turn the sun into a strange looking crescent. Looks like it'll look like a crescent moon, but a lot brighter than that. And then the moon will uncover it. So by the time we're finished with all this, it's going to be somewhat after 5 o'clock in the morning Eastern Time, 2 o'clock in the morning Pacific Time. And wow, in the Universal Time, if you're there in England, we're talking about after the start of daylight. You know, a little bit after 9 o'clock in the morning time. So that's our schedule, and we're going to be watching this thing with you with a lot of different things. You're not going to have to suffer through looking at me this whole 4 hour show. We're going to be watching several or 3.5 hour show. We're going to be looking at several other great aspects of it. Solar experts, interviews with people who really know what they're talking about regarding the sun, and other cool stuff. 1 minute to go now. We've got a 1 minute countdown till the beginning of this eclipse. Eclipse of the sun. They're linked, eclipses of the moon and the sun. We'll talk about that in a little bit because coming up in a couple of weeks, we have probably the one single headline celestial event of the year in the United States and Canada. And that also will be an eclipse when the moon is on the other side of this same node. So those nodes are now aligning. Your stars are aligning. I'll give you a little astrological reading while we're at it at the same time. Just kidding. Here we go. Countdown to 15 seconds now, 14, 13, when the sun is going to perfectly be aligned with the moon. The moon's going to actually slide in front of it. Here we go. 3, 2, 1. And the eclipse, unless the laws of physics have changed, unless the Earth or the moon have changed their speeds in their revolutions around the sun or around the Earth, respectively, the eclipse has started, and we'll be using equipment to zoom in and take a look what that looks like more close up coming up just shortly. The greatest eclipse in terms of extent, how much will the sun be covered? As I said, it's 79%. That's going to happen at 12:40. This is the start. Greatest eclipse is at 2:54 Eastern time, and in Universal time that's 6:54, and a little bit before midnight in Pacific time zone. So it's a nighttime event here. So we're going to here tune in on this, point the telescopes at this, and see when we can first observe the moon's intrusion onto the sun's edge as it has reached the node of its orbit around Earth. And again, that node will be lined up enough so that 2 weeks from now, we're going to have the mega harvest moon. And that's when the moon will go into a total eclipse. Some of the media are calling that the blood moon, but let's not get too dramatic. The moon actually turns a coppery red, kind of an orangey red. If your blood ever turns the color of the moon when it's maximally eclipsed in a lunar eclipse, if you ever see your blood that color, you should go to the emergency room. So it's not really a blood moon. But it will happen on the same moment that the moon is at its closest point to Earth of the entire year, just as the moon comes closest to Earth in its elliptical orbit. Just then, which is also the night of the harvest moon, it will go into total eclipse. How cool is that? That happens in 2 weeks. Part of this same cycle, really, because it's part of the same process of a lineup of the sun and the moon and the earth. So this is eclipse season, really is. And, stick with us while we bring you various aspects of it, including these live views of it. This is from South Africa. Paul Funk is the person we have to thank for it. The cloud briefly comes and goes. That's because it's live. We're seeing it just as it's actually happening. So this is Slooh. We do this kind of thing, bring you comets when they come close up, asteroids when they skim nearby, as some have a little disconcertingly been doing in the last few years, and events like meteor showers and total eclipses, all the amazing, dramatic, inspiring, and very cool stuff when it comes to the universe and observing the universe. You'll always see it here. This is where you'll find it live. Yeah, you could read about it the next day in various media. This is where you're going to see it live. So, a lot of fun. We have fun doing this. This involves people on several continents producing this and bringing this to you. And other aspects of this will be coming down the pike as well. As we see the sun slowly climbing into the sky, we're going to be zooming in on it using equipment and looking closer views of the sun as it goes into eclipse. This is a pretty deep eclipse at 79%. That's enough to change the light to make the sun look truly weird. Later on, I'll talk about how to observe this yourself. I know you're not there, unless you are there. We have viewers and listeners all over the world. So maybe you are in South Africa, but I'm assuming you're not. And if that's the case, welcome. Thanks for joining us here at our Slooh coverage. So stick around. I'll be back in another 2 hours, and then I'll be back again later on in the eclipse. In between, we have other people, experts, guests, other segments, all sorts of amazing things as we watch the eclipse begin. It has just begun, so the moon is just barely touching the edge of the sun. Too soon for us to see detail, but that's going to come up before you know it. So stay with us. I mean, wow, we're going to be doing this right through the night here in the United States. Nighttime event. Okay, I'll be back a little later for Slooh. I'm Bob Berman. I'm Bob Berman for Slooh, and let's talk about eclipses in general, solar eclipses. Because it's mysterious to a lot of people, it certainly produced lots of superstition and lore and legend before the science started kicking in during the Renaissance. We now understand it pretty exactly, and it involves three celestial bodies: the sun, the moon, and our own beloved planet Earth. It also has to do with lineups or alignments. As the moon goes around the Earth once every 27.32166 days, its orbit changes. That is, the orbit isn't stable, but actually changes its orientation in space. So the moon appearing in front of the sun from our perspective, and therefore blocking out the sun, does not happen on the same date every year, because the exact direction toward when the moon can block out the sun changes. You see, the moon's orbit is tilted 5 degrees. 5 degrees is just enough so that most times at new moon, which is when the moon is between the Earth and the sun, it passes above the sun or below the sun, not directly in front of it. The only time it can be straight in line and block out the sun is if it goes from its tilted low point below the Earth-Sun plane to above it, and that's called a node. Only then is the lineup absolutely perfect in 3 dimensions. And that nodal point, as I said, moves along. It actually precesses or regresses in actuality because it happens earlier and earlier each year. Bottom line to all this is that once you get an eclipse where the moon is blocking out the sun, the next time will happen roughly 6 months later, when that lineup of the nodes, the exact 3-dimensional Earth, Sun, Moon plane, again is lined up, but then in the opposite direction, but still there'll be that 3D plane. And all that time, that moon's orbit mechanics is moving in the opposite way, making it a little earlier and earlier. So let's say you get a total eclipse on, which we did this year, on March 20th. Well, if there's going to be a total eclipse of the sun, where the moon is directly in front of the sun, the next year it'll happen 11 days earlier, on March 9th. And that's exactly what happens. Meantime, if there's going to be any other kind of eclipse, that will be about 6 months. So these days, the eclipses, or eclipse seasons, as they're called, happen in March and September. So we had our total eclipse of the sun on March 20th. And this also applies to lunar eclipses when the moon goes into Earth shadow, because the same requirement is there, that the Earth and moon and sun be on a straight line in 3 dimensions. So we had a total eclipse of the moon 2 weeks later after that solar eclipse on April 4th of this year. We covered that here at Slooh. And now we've moved to the other side, that 6 months later period, and now we get that partial eclipse of the sun. We'll talk about the partial eclipse details in a moment. Now, in the middle of September, September 13th. And now, 2 weeks later, when it's full moon, so happens it'll be the harvest moon, that lineup still is complete enough to allow us to have a wonderful, yummy total eclipse of the moon on the night of September 27th to 28th. So these days in March and September. But remember, they slowly swing earlier and earlier. So next year, it's going to be happening in early March. And it's going to be moving from September to early September or late August. And by the time we get to the year 2017, whoa, then we're going to have a total eclipse of the sun happening on August 21st. That will be the first total eclipse of the sun in 38 years in the United States. Wow, that's going to be something. So this brings us inevitably to total eclipses versus partial eclipses. Obviously, if the lineup is perfect and the moon goes perfectly in front of the sun, it can produce a total eclipse. But wait a minute, one other detail. The moon, as it goes around Earth, sometimes is closer to us, sometimes more distant. You know about that because the media keeps talking about the mega moon. Even we get on board that ship here at Slooh. The mega moon, meaning a very close moon. The moon can be closer. You can have a big full moon. That's what we're going to have on the harvest moon date on September 27th, just 2 weeks from now. And then the moon can be as much as 14% closer than it is when it's farthest away in its orbit. So in other words, it's not a round orbit, it's an elliptical orbit. Sometimes the moon is closer, sometimes it's farther. Well, if the moon happens to block the sun when it's at its farthest point, or even anywhere in the farthest half of its orbit, it won't appear large enough to do the job. So even if the eclipse is central and the moon slides directly in front of the sun, the best it can do, if you're located in the perfect spot on Earth, is block out the sun but leave some sun around it. So there's kind of a ring, Latin annulus. So it's called an annular eclipse. It's not a total eclipse of the sun, even though the moon passes centrally in front of it. So the moon also, on top of everything else, has to be in the near half of its orbit and appear large enough to fully cover the sun. So that's what will happen next year in early March, and especially on August 21st of 2017, when we're going to get that 2.5-minute long totality in the United States of America. Wow, that's going to be so cool. Most of the time, though, the alignment isn't perfect enough, and even though the nodes of the moon-sun orbit, that flat plane, is lined up, the moon still just brushes the side of the sun. You'd have to be somewhere in space other than planet Earth to see a total eclipse. And then we get a partial eclipse, and that's what's happening today. So the moon blocks out the sun, but it grazes it. It doesn't pass centrally in front of it. In the eclipse today, the most that's going to happen is about 79% of the sun will be blocked out. That's pretty cool. The sun will be reduced to looking like a crescent moon in the sky. And it's very, very amazing to watch. Now, no sense pretending it's as amazing as a total eclipse of the sun. You see, the moon's shadow tapers like a chopstick. It gets narrower and narrower, and it ends just about where Earth's orbit is. So by the time it gets to Earth, the moon, which starts out 2,160 miles wide, that shadow gets down to only about 140 miles wide. Not very much when it hits Earth's surface. And so it produces a band, a ribbon. And if you're inside that path, that narrow highway, only 140 miles wide or so, then you can see a total eclipse. That's when the stars come out in the daytime. That's when you look in the sky and see the sun totally blocked out. You can see geysers of nuclear fire streaming into space around the blocked out sun's edge. The sun's corona, or atmosphere, spreads across a big part of the sky and shows interesting details thanks to the magnetic field of the sun. So many things happen. Animals go crazy. People weep. It's very scientifically useful. And so total eclipses of the sun, those are the prime major events in nature. And that's why we bring you every single one, even though at Slooh, boy, we've got to bring people to usually odd parts of the world to see them, because you've got to be in that narrow path of totality in order to get it. This time it's happening in the extreme southern tip of Africa, but you got to go somewhere in the world to see it. But it's worthwhile. It's just an amazing, amazing experience. Total eclipse of the sun. They're pretty rare for any given spot on Earth. They only happen once every 360 years. And then if it's cloudy, you'll have to wait another 360 years. So they're pretty rare. Although most years they occur somewhere on Earth. 3 out of 4 years there's a total solar eclipse somewhere. So this time it was closer to Iceland. This year, next year it'll be in the steamy Indonesian area, and the year after, fortunately, in the United States. As for partial solar eclipses, they are less scientifically useful. They're still cool, but they're not as mind-blowing as a total eclipse. So these happen over a much wider range. But this particular one, not where we live, if you're an American or even live anywhere in North America. This is strictly for Antarctica and the southernmost areas of Africa to see this. That's kind of different, in fact, very different from a total eclipse of the moon, because the moon is going into Earth shadow and it's seen by everyone who has the moon in the sky. So when you see a lunar eclipse like the kind we're going to get in just 2 weeks from now, half the Earth sees it. As long as you have the full moon in your sky, you'll see it going into eclipse. But those solar eclipses, those are much more special and require travel and require special planning ahead of time, because that's just a particular region of Earth, especially for a total eclipse. So we're enjoying the one that we're seeing today, our partners in Africa, to see for ourselves what it looks like when the moon blocks out the sun. Or put another way, that's the region of Earth where the moon's shadow is brushing today. So that's our basics about solar eclipses. For Slooh, I'm Bob Berman. Hi, I'm Bob Berman for Slooh, and our special guest is Dr. Lucy Green, who is a solar expert, a researcher. This is someone who really, really, really knows the sun inside and out. In fact, we're going to talk about the inside of the sun as well as the outside on this occasion of a solar eclipse. How are you doing, Dr. Green?
I'm doing very well. How are you?
I'm good. I'm good. Sun is shining, and boy, we're going to be exploring this eclipse. So, and we've got some total eclipses coming up too. So I think maybe we'll talk about the rhythm of eclipses as well. But first, and I'm going to call you Lucy for the show instead of Dr. Green. But what does this bring out in you? Do you howl at the sun during an eclipse? What aspect of the sun conjure makes this evocative for you?
I suppose there's probably two sides to it because there's the science side of me that gets excited that I want to use the opportunity to study the atmosphere of the sun and also do interesting things with checking our instrumentation that we can talk about as well. But then there's the other side of me that just likes the spectacle of a solar eclipse. And I watched the partial eclipse that we saw from Britain earlier on this year. And I just stood outside and I watched the phases go through and completely enjoyed it and did absolutely no science at all. It was wonderful.
Great, great, great to hear. And as long as we're mentioning watching the eclipse, I guess we should remind people again, because this is what our attorneys would tell us to do if we had an attorney, and that's to make sure you use some kind of eye protection for a partial eclipse or for the partial phases of a total eclipse, because you can fry your eye. The sun's rays, even just the infrared, the heat. Forget about the ultraviolet. The infrared can be focused onto your retina, and it can quite cook it. So here, for example, is a welder's goggle. Shade 12 or 14, both will work. There's been some controversy in recent years as to whether you really need one or the other, but both will work equally well. Or you can send away for Eclipse goggles. Just don't stare at the sun without any eye protection. And I'll bet you didn't make that mistake, did you, Lucy?
No, we had quite a fun time actually.
Mhm.
So, because we had a partial solar eclipse, we always had to have some way of either projecting the image or, like you say, looking through a filter to protect your eyes. So, we set people a challenge to come up with quirky and unusual ways to view the sun safely. And my favorite was that I took a colander from my kitchen, which is just a device that you would strain your vegetables in. It's like a sort of dish, a metal dish, and it's got these small round holes in it. And I used that to create a pinhole image of the sun during the partial eclipse, and we had lots of them scattered all over the ground as the light fell through all these different holes. So it was really good fun. I don't know. Do you use any interesting or strange devices to view your partial phase?
Well, I've never heard of a colander before, but it's a wonderful idea, and it would project a number of solar images. So, in a deep partial eclipse, when the sun turns into a crescent, imagine looking on the ground and seeing dozens of crescent suns projected by the colander. Marvelous, marvelous idea. I'm trying to think of something that might top that, but I can't think of one. I think that's great. Were there any other entries? You said there was a kind of contest into
The other
original
one,
ways of.
yeah, so the other one that I liked was somebody had a metal teapot, and in the lid they had a tiny little hole around where the sort of in the middle of the lid, and they opened that up and let the sunlight fall through. So I think that was probably the quirkiest one. We got people tweeting about it and sending their photos in to us. But anything with a small hole in it will do.
Marvelous. And that's from the fact that the sun, even though you'd think that there's no cameras around, any little opening can actually act as a pinhole camera and project the sun's image. This starts from an Arabic man named Al-Hazan about the year 1000 AD, who would set up his tent in the desert, and people would come from all around to look at the images of the surrounding terrain through his pinhole cameras. He was quite, this was during the golden 3 or 4 centuries where Arabic science was at its peak. and uh, and so he kind of popularized that. But anyone can scrunch up their fingers, for example, and make a little opening in their fingers, and let that project to the surface of a white surface, preferably a sidewalk, let's say. And instead of the irregular shape that you're going to produce in your fingers, you'll see perfectly round shapes because that's the sun. You're actually projecting perfect round sun images even out of your scrunchy, non-round little openings. So it's marvelous during a partial eclipse. How deep was the partial eclipse that you had in England?
Where I was, which was in a place called Leicester, in the sort of the middle of England, we had about 85% of the sun covered. And it was quite surprising to me that there was a noticeable colour in the change of the sky as well. The light sort of took on this more of a purple hue. And I wasn't thinking that we would see that given 85%. I thought that there would still be enough sunlight to make it look more like just a cloudy day, but instead it was markedly different. It was very beautiful.
That's marvelous. And that's why our viewers joining us for the eclipse, this one can only be seen from extreme South Africa and from Antarctica. But of course, each year offers one or two solar eclipses, usually partial, but 3 out of 4 years, there is one total eclipse. And we've talked about this before, Lucy, that there is no spectacle of nature that can compare with a solar totality. Really cannot, and that's why we urge all people who can to travel to see one. They're usually in hard to reach places, and it's only a small part of Earth because the moon's shadow tapers like a chopstick. And by the time it reaches Earth, it's down to about 140 miles wide from its original 2,160 miles. So you got to be in that very narrow part of Earth, that little path, in order to see it. The big one that we're getting excited about, and Lucy, I hope you're going to come to America for this, of course, is on August 21st, 2017, now less than 2 years away, when we will have a coast to coast totality in the United States, the first total eclipse in the mainland U.S. in 38 years. Will you come and observe it from here?
I definitely will. My colleagues and I are talking about that already. We haven't decided exactly where to go, but the thought that there's such a wide area that you can choose from. So actually, the thing we haven't looked into is where we have the best chance of having clear skies. So maybe you could give us some advice on what part of America would be best.
Oh, I'd be happy to. You know, we have a science tour company, and we already have the place advertised. We're combining the tour with a visit to the NOAA and the Climate Center and NIST, the National Institute of Science and Technology. But let's put it this way, without getting into too much detail. Right now, the track goes from the Pacific Northwest to the southeastern states. But you, of course, don't want to be in the Pacific Northwest because that tends to be cloudy and rainy. And you don't want to be in the southeastern states either because this is afternoon. By that time, the eclipse starts in the morning and becomes afternoon by the time it reaches places like Tennessee. And in August, that tends to be very steamy and cloudy in the afternoon. So that's not good either. So aim for the middle part of the eclipse. We're talking about going through places like Indiana, Wyoming, Idaho. These are sunny places and tend to be clearer. And I'll let you know privately, Lucy, where we're going, or you can actually look it up under, you know, our tour company, special interest tours, or go on your own. And my goodness, this looks like an excellent opportunity. Of course, for people who cannot travel, as always is the case at Slooh, we send a team and we'll capture it so that you can just stay at home if you wish and watch it on your own monitors, computer monitors. And Lucy, I won't spill the beans. You tell everybody, why is a total eclipse? How does that differ other than the fact that more of the sun is covered? Why is that more interesting than a partial eclipse?
So I think for me, it's more interesting because the change is so more so much more abrupt, and you get to see a part of the sun's atmosphere during the total solar eclipse that you don't get to see during the partial phases. Well, in fact, you get to see two different parts of the atmosphere. So you get to see the layer called the chromosphere, which is this sort of red ring very close to the photosphere, just sitting above that visible surface of the sun. And that sort of flashes into view. You might see it just at the start of the total phase and just at the end of the total phase. But really, the big reward for seeing the total phase of the eclipse is to see the corona. So, to see the outer atmosphere of the sun, which is this 1 million-degree atmosphere, very, very thin gas and electrically charged gas that is very hard to see. So, from the ground, you see it during a total solar eclipse. From space, okay, we can use different techniques, and we can use cameras that pick up the X-ray and the ultraviolet emissions from this 1 million-degree gas. But the total phase is exciting because suddenly this flares into view and you can see it from the ground for those few seconds or those few minutes. And that is absolutely spectacular. And I think whenever I think about having seen the total solar eclipse in 2009, which is the only one, the only total I've seen successfully, actually. And I just thought it looked like someone had shot a hole in the sky, this little dark moon covering the sun, and then the fantastic corona all the way around it. Absolutely spectacular.
We are very, very close to totality. I think I just heard the shout saying 1 minute. Now, we were hoping to bring you some live images of this, but you can see it in the background. Because of the dust storm, we had to drag all of our equipment in, and people were hanging onto tents and all over the place. It was amazing. It was one of the most exciting things most of us have been involved with. But now is the time, and I'm going to talk. Naturally, I started talking quietly because suddenly it's going dark. Not a normal kind of dark. This is one of the most eerie. Wow. Totality is just seconds away.
It's there. 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 And it's gone.
Right, now, are they going to change the filter for us? Please.
We wait and... Oh!
Eric!
Oh,
Whoa!
goodness.
There's totality, and it still looks wonderful through the clouds. It is spectacular. That's amazing. And there's the diamond ring. The diamond ring did bang! And the sun just came out in time for us to witness totality. I'm sorry. I'm emotional.
really defies description. I mean, we know the science behind it. We know the moon's speed. We know about the orbital parameters, and we understand all that. But something happens when the sun and the moon and your spot on Earth form a straight line in space, and you actually see this celestial clockwork mechanism happening right before your eyes, and the moon covering the sun, and that corona, that sun's atmosphere, showing detail because of the magnetic. These are charged particles, so they're sculpted by the sun's magnetism. So it shows tremendous detail, goes farther across the sky than you'd think. The brighter stars come out in the daytime. Often there is a eclipse wind because for the 1 hour of partial eclipse, that resembles what we're seeing with the current eclipse. Every total eclipse starts out with an hour long partial eclipse, and during that time, the air temperature is dropping. This often sets up a wind, an eclipse wind with a haunting howl to it, like that. The colors, you mentioned them earlier, Lucy. All the colors get strange. Everything looks highly saturated. The details on the ground, shadows have crisp edges because the light source is increasingly just a point of light instead of the half-degree sun. So earthly objects take on an otherworldly look to them. And so, in all ways, it's a hauntingly beautiful, unearthly experience, unlike any other in life. So, while we are currently seeing a partial eclipse of the sun, very nice watching the moon cover up the sun. I mean, fabulous that we should have this kind of alignment. Uh, we always count the days to the next total eclipse, don't we? My goodness.
Mm. Yeah, absolutely. And it's interesting that they're still really valuable for doing scientific research as well. So you would think that in the modern space age, when we have telescopes in orbit around the Earth and we have, 24/7 views of the sun, including creating an artificial solar eclipse in space using telescopes called coronagraphs, you would think that we had nothing to gain from studying total eclipses from the ground, but actually we still do. So these beautiful shapes that you talked about being sculpted in the atmosphere of the sun by these magnetic fields, we want to watch them, we want to understand them, and we want to understand any changes in those magnetic fields that might produce dramatic activity or just be an indication of how the sun is operating as a star. And during the total eclipse phase, we can still get really valuable information. So things like studying in very high detail using a fast sequence of images. So this is the great thing about observing from the ground is you can set your camera running and you can take very high cadence images, so at a very high frequency, and you can see things changing rapidly in the sun's atmosphere. And that's quite hard to do from space because we have to gather the data, send it back down via a radio link, and you don't necessarily have the opportunity to have such high data rates when you're doing that.
Yes, fantastic. And I know there are current fields that didn't exist just a quarter century ago, things like helioseismology, where again, using spacecraft, we're measuring the pulsations of the sun. And just as earthquakes tell us what's going on underneath the Earth's surface, these pulsations can reveal what's under the sun. So let's go from the magnetic field that surrounds the sun's magnetosphere, to the still enigmatic area. I'm going to ask you about that. I think it's fairly recently that we've learned that the magnetic field of the sun originates in an area 70% of the way from the sun's center to its edge, a region called the tachocline. Fantastic region that separates the place where the sun spins as if it were a solid ball inward of that to where it's a differential rotation. I know the equator of the sun takes about 25 days, the poles maybe almost 10 days more. So the boundary between those two, the tachocline, is fantastic. Now, is that an area that you study or know about? I mean, what can you tell us about that?
Yeah, so you're right. This is a fascinating area, and I don't study it directly. so I have colleagues in Britain and in America who do, and I go along and I talk to them and I read their scientific papers, because I'm interested in the sun as a magnetic object. I'm interested in the magnetism, in its magnetic field. You talk about it, you spoke about it having this magnetosphere, so like the Earth does, but the sun's magnetic field is quite different in the fact that it is changing very rapidly. And this tachocline region that you talked about is where we have a constant change in the magnetic field, in that it's growing in strength, and it's changing inside the sun. And what's happening is a solar dynamo, a magnetic dynamo, is operating down there. So these different flow speeds that you talk about have a really big impact on the sun's internal magnetic field, and it has the effect of amplifying it in strength. And that then has this really interesting knock-on effect, where if you amplify the magnetic field enough, you can end up having sort of regions or portions of magnetic field actually rise up through the sun and burst through the surface, creating the sunspots, and then creating these structures in the atmosphere that you talked about that are visible during a total solar eclipse. And it's all, this magnetic field evolution is all being driven by these very, very interesting flows inside the sun. I think the sun as a magnetic object is really interesting, and that's what I study, but it's worth sort of thinking about magnetic fields in a slightly different way. I visualize them as being like elastic bands that can be stretched and twisted and deformed, and that's very much what the magnetic field of the sun does. So I study the magnetic field once it's emerged through the surface to form the sunspots, and then has further emerged into the atmosphere, and I study what happens to it then.
Hmm. Now, I understand. Tell me if this is true, that a sunspot, such as the ones that we are uh, glimpsing today during this eclipse, the that the sunspot can have a magnetic field strength that's 5,000 times greater than that of the surrounding region of the sun. Did I get that wrong, or is that really correct? Can it be that much of a
Yeah,
difference?
they are much, much stronger, and that's because they have been born out of this very strong magnetic field inside the sun, and they get lofted up on currents of rising gas that come to the surface of the sun, and yeah, and they burst through as very strong features, and then all around in the surrounding areas is a much weaker field, that's much more dispersed, well, spread
Hmm.
out, and less concentrated.
We're talking with Dr. Lucy Green, astrophysicist. This is a top solar researcher. She's in England, if you couldn't already figure that out from what we would see as an accent, although I'm sure she does not hear that as an accent at all for herself. Let me ask you, Lucy, um, some solar researchers are now thinking that the sun may be entering a prolonged period of weirdness where its activity is much less. This is based on that long 14-year instead of the normal 11-year sunspot cycle number 23, and the long period of sunspot minimum. That was a very deep minimum. And I believe this new solar maximum from last year, number 24, was only about half or so the strength of normal. So some solar researchers are thinking that the sun is maybe beginning an extended period, which in the past has correlated with cooler weather on Earth. Could do you subscribe to this? I mean, that would help us out, wouldn't it, with global climate change?
Definitely, if the sun were to reduce in the amount of energy it sends our way, then we might have a knock-on effect on the Earth. But you're right that the sun has been acting in a very interesting way, and it's been really great to see the sun changing before our eyes on a timescale that we can appreciate, on the timescale of someone's career. To be watching a change in our local star is fantastic. And so, yeah, so we've had this time where the number of sunspots has been a lot less than we were expecting it to be. And I remember before cycle 24, the one that we're in at the moment, started, there was a panel put together in America to forecast how large this cycle would be, how many sunspots would be on the sun, when would the number peak, in other words, when would the cycle reach its maximum phase. And there were all kinds of predictions, large numbers, medium numbers, and perhaps a little bit smaller. But the size that this cycle has turned out to have, is much less than any of the predictions. So it has really been what we call, or what has been called now, a mini maximum, because I think it's about half the size of the prediction. And in fact, as time went on, people revised their predictions, and they kept making the solar cycle size smaller and smaller and smaller, and pushed it back in time as well. So we clearly still have a lot to learn about predicting the size of solar cycles, but that's understandable, because what we talked about earlier was that it's being driven by processes inside the sun. So processes that amplify the magnetic field and cause it to loft up to the surface and create the sunspots. So the sunspots are surface manifestation of the solar cycle, of the solar dynamo. And and so we still need to understand a lot more about what's happening inside the sun, the physics of what's happening inside the sun, to predict the size of the solar cycles. So it shows us that we still have a long way to go, but that's what science is. It's always a series of questions. You answer one, and another 10 questions get opened up at the same time. But I think we still have a lot to learn about the longer timescale evolution. So going back perhaps over 400 years, which is the time over which we have the sunspot observations, and over which you see the cycle rising and falling. And certainly, there is still a lot of debate, actually. And I was at a conference earlier on in August where there was some work presented that showed the sunspot data has been reanalyzed. So what I mean is that they've gone back through all the archives, through all the observations from the 1700s and 1800s, and even before that, even into the 1600s, to just check, what did those very early observers see, and what did they record, and can we trust the data? Have we interpreted it correctly? And they actually suggested that perhaps the sun isn't doing something unusual. Now, I'm not sure that everybody agrees with that, but I just wanted to say that to show that it's still debated. Is the sun acting unusually, or actually did it do this kind of thing in the past? What is the normal character of the sun is what we're still trying to work out.
Yes, that makes sense. But I think nobody disputes that this last cycle, from the last sunspot maximum to this one, was longer than 11 years. And as you've just said, this maximum was half the strength of a normal maximum. So any way you slice it, it's been an odd sun. For people who don't know, the normal flux, if you put out a square meter on the ground, you get 1,366 watts. That's the normal insulation from the sun. And during a sunspot maximum, it would rise up not even nearly to 1 watt more. So it's not that much in the visible wavelength, but in the ultraviolet, especially in the some parts of the ultraviolet, the far ultraviolet, there's a big range. And this apparently has trickled down, not fully understood effects on our atmosphere, on our climate. And so you're very wise not to stick your neck out and take the bait and predict whether the sun is going to be cooling us down and mitigating global climate change. That was smart of you not to take that bait on that, but very wise and cautious for you to simply say that it's not understood, and there's a lot more that we have to learn. So while we watch this eclipse, this grand meeting of the moon and the sun and the earth, it really reminds us of how powerful the sun is and how much more we still have to learn. When maybe we can talk a little bit about this cycle and when we're going to again see this kind of a cosmic lineup. I know one of them is going to get you to America. That's great. what kind of this lineup? The next time that this happens, we're still not going to get a full eclipse, but we will next March, won't we? I wonder if you'll be, or any of your colleagues are going to go to that one, or is that around Indonesia? Is the weather going to be too cloudy and steamy and unfavorable?
Yeah, so I think for us, the American eclipse is the one that we're working towards. But yeah, it takes us a bit to to mobilize ourselves. I mean, I have some friends who are eclipse chasers, and certainly they're interested in going anywhere that there will be a total solar eclipse. And some of them have instrumentation that they'll be using to look for example, waves in these magnetic structures in the sun's
Hmm.
atmosphere. But for me, it will be the eclipse in America. That will be the next one for me.
Hmm. Well, we should also remind everybody that since the moon is now at a node in its orbit, that's a crossing point. It has a orbit that's tilted about 5 degrees from the Earth-Sun plane. We can only see an eclipse when the moon is passing from below to above or above to below. It's so that in all three dimensions, it's on a straight line. That's what's happening now as the moon passes in front of the sun. But in 2 weeks, when it's on the opposite side of the same node, the lineup again becomes good enough for the moon this time to go into Earth shadow because the sun, Earth, and moon will be lined up. And we want to remind everybody that that's going to happen, strangely enough, just as the moon reaches its closest point to Earth of the entire year. The closest lunar perigee of 2015 will occur at the time that the moon is full and is going into eclipse. So the media are already calling that a mega moon, super moon, blood moon. You know, there's all sorts of words for that. But bottom line is don't miss that. That's the same kind of lineup that we're seeing today, which is allowing the sun, earth, and moon to be in a straight line, will repeat, but with the moon on the other side, where Earth is in the center of the three celestial bodies, syzygy, as we Scrabble players like. Actually, it's not a very good Scrabble word because you'd have to have three Y's, and there's only two in the game. But reminding everybody that to stick around for that. That'll be our greatest lunar eclipse of the year. And the next time we have any kind of solar eclipse or need help with understanding the sun, we immediately turn to Dr. Lucy Green, who knows about it, even though she keeps saying that we don't know as much as we'd like, and we're learning more, and we'd like to learn more, but still, she knows more than any of the rest of us. So we'll come back to you, Lucy, if you'll be so kind to come on again the next time we have a solar event like this. And
Yeah,
so thank you. Thank you so much for joining us today. This was a big help in having us understand the sun a little better than we did before.
thank you. Enjoy the eclipse.
Okay, thank you. Hey, this is Bob Berman. I'm back. Hasn't this been cool? Wow. We've been watching this live solar eclipse from South Africa. It's been so cool. In this last segment, our thanks to Alan Versfeld, one of our feed partners. We've been bringing it to you in real time as it's happening live. We've just been watching the moon go in front of the sun and now slide off the edge of it, just in case anyone mistakenly thought that this was a total eclipse, even though we've said so and written it, and you can see it in front of there. This is a partial eclipse over South Africa. Still a lineup of the Earth and the Sun and the eclipse. And look at those sunspots. This is great too. You know, here at Slooh, we have periodically a fantastic solar telescope. One of our Slooh people, as we bring this to you right from um, Arizona, the Prescott Observatory, a solar observatory, and we bring you these stunning views, both in visible light and in what's called H alpha light, offering detailed looks at the sun's granulation and sunspots and faculae and prominences. They look like nuclear flames or geysers leaping off the edge of the sun in tremendous detail. And so look for those shows coming up too. In fact, we have some very cool stuff on Tuesday night. We'll have a live view of the International Space Station. This is Mankind in Space. That's going to include an interview with the Director of Human Resources at the Johnson Space Center. And we're going to talk to him about there's nobody who knows it better than him. He's the guy who has designed many of the experiments, how they're getting ready to send people to Mars, and what's coming up with our human beings in space and what it does to you, and radiation and muscle loss and bone loss and all the what's going on. We're going to be watching the International Space Station as it passes overhead live. And then 2 weeks from today we have the mega harvest moon eclipse. That's not an exaggeration. We'll have the closest moon of the year. You know, the moon's orbit is not round, it's elliptical, so it's going to come very close to us, closest hour of the year, just as it's the harvest moon and just as it goes into Earth's shadow and turns a coppery red. The media are going on a feeding frenzy with this one, calling it the blood moon, the mega moon, the harvest mega super hyper blood moon, all sorts of things. You'll see it as headlines and wherever you get your news, but here at Slooh is where you're going to see it live. You're going to watch it happen. Join us for that, please, and maybe schedule a time where you and your friends, your date, your loved ones, your pals, your family, whoever, grab them, take them outside for that, but keep Slooh on. So we'll be talking about it, telling you what's going on while you watch it. Either here, we'll bring it to you big and live right on your own computer screen, or head outside and watch it while we explain what's going on with our various experts and guests here. And that's coming up in 2 weeks from now. This evening, if you're in the northern hemisphere, we've been watching the moon covering up the sun. So cool. The eclipse of the sun has been seen from South Africa. It's actually continuing if you were near Antarctica or in Antarctica. It goes on. So, depending upon where you are in the world, you'd see it. Well, let's face it, who's in Antarctica? Almost nobody. So, essentially for the world, it's over because South Africa is the last truly populated place, as the moon has cast its shadow on Earth. Partial shadow. Let's be clear about all of that. In a total eclipse, the sun is totally blocked out. You can see the flames of plasma on the edge of it. The stars come out in the daytime. The corona, the sun's atmosphere, spreads into space and takes on an appearance that's unique in each eclipse. It all depends upon the sun's magnetic field at the time, and it varies with its sunspot cycle. Speaking of which, We can see some spots right now, and those storms on the sun, those sunspots, are influential to Earth. We see them very clearly when we give you our Slooh views from our own Matt Francis's Prescott Solar Telescope. But even here, you can see them pretty nicely, thanks to Alan Versfeld, who's bringing these images from South Africa at this moment. And as we watch the sun, the moon just skedoodled from the edge of it, just disappeared. But the sunstorms are making news because although it's generally an 11-year ebb and flow of these storms, the last maximum was around the year 1999, and then we expected a minimum, and then the next maximum would have been 11 years later, around 2012. And guess what? Did not happen. In fact, 2011 is when it was scheduled for. Did not happen. Instead, the minimum was prolonged and so deep that there were fewer spots than anyone now alive has ever seen. So the sun's behavior was unprecedented so far as the generation of humans that are alive today goes. And then when the sunspot maximum came back, delayed and delayed until finally scheduled for 2013 to 2014. In other words, last year or the year before, when it finally came back, it was only half its normal strength. And that's a big deal. It was such a wimpy maximum after that long, prolonged, very deep minimum that many solar experts, most, are now predicting that the sun has entered an extended period of inactivity with consequences here on Earth. When the sun does that, Earth gets cooler. So perhaps it is coming to our rescue and mitigating climate change, making climate change less extreme for maybe even decades to come. We can hope so. That would be very convenient as we perhaps phase in remedies for all the carbon dioxide we're throwing out into the atmosphere and maybe reducing that. The sun is coming along and keeping temperatures from rising as much as they might otherwise have done. At least that's the way it looks. You know, the sun is still mysterious to a degree. We're learning more and more about it. The new field of helioseismology, which looks at pulsations on the sun, and the armada of fabulous solar spacecraft with names like Source and Stereo and SDO, the Solar Dynamics Observatory, along with old ones like Trace and ACE. And wow, it's an amazing time to be looking at the sun and studying the sun. And here at Slooh, we're a big part of that. And hopefully, we will remain a big part of your observations of the sun as well. And because that's what we've been doing. That's what we've been staring at, and we'll continue to do so. Whenever there's a celestial event, an eclipse is one such, meteor showers, we have special low light video cameras, and we'll bring you the Geminids, which will be the best meteor shower of this year. 100 meteors per minute, we believe, will be seen. That's in December. And between now and then, as I said, we've got some great shows coming up. Perhaps the most headline worthy is the one in 2 weeks when we have the mega harvest moon. Don't miss that. Definitely join us for that. So we're really grateful that the weather cooperated in South Africa for this event. Hope you've also enjoyed our interviews, our other guests, experts, solar researcher Lucy Green, the other cool stuff that we've been presenting here as we look at the sun, our beloved star, 93 million miles away. Let's think of it in terms of that the sun is 100 sun diameters away from us, about 108 actually. So imagine that ball of the sun. Let's not underestimate it. 1 million planet Earths could fit inside it. If it were hollow and you could unscrew the top of it like a mayonnaise jar and just throw planet Earths inside, it would take 1 million Earths to fit inside the sun. That's how large it is. And the distance, 100, a little over 100 Earth balls would fit between our planet's position in our orbit around it and the sun. And the mysteries keep getting solved, some of them. In 1920, we finally learned why the sun shines. I mean, it was a pretty big enigma. It had been calculated that a ball of coal the size of the sun, weighing what the sun weighs the same as 333,000 planet Earths, pretty massive item, and it's giving off a lot of energy. We can easily calculate how much. Every square meter, roughly 1 square yard of Earth's surface, receives the same as 1,700-watt light bulbs in intensity, 1,366 watts of energy. That's per every square yard. And there's a lot of square yards on Earth. So it's a lot of power coming out of the sun. So we knew the power, we knew the size, and now we finally learned what makes it shine. If it were a lump of coal, it would have burned itself out in just 2,000 years. So it couldn't be any kind of normal burning. Very enigmatic. As I said, it took until Arthur Eddington finally figured it out in 1920 that it was fusion, new process we didn't know about, where hydrogen, which is its primary constituent, fuses together. Four hydrogen atoms fuses together to create helium. And in that, sounds like a boring thing to do, but every time it does that, a little bit of mass turns into energy. All in all, the sun is using up a lot of its mass. Every second, it's 4 million tons lighter than it was before. It's a lot of mass that's being lost in its conversion to energy. One of the reasons we study it and look at it, and still going to last, by the way, for about 5 billion years. Don't worry, even at that prodigious rate of energy output, it's got a lot of mass. It'll keep working. So this concludes our Eclipse show. We've been watching this for hours now. Hope you've enjoyed it, all the different aspects of it. Again, a reminder, tune in on Tuesday night for our International Space Station show. I think you're going to really love that one. We're going to track it live. And then 2 weeks from now, we'll see the mega harvest moon. Wow, a lot of great stuff coming up. Please be here for that here at Slooh. For Slooh, it's been my pleasure to be with you. I'm Bob Berman. We'll see you next time.
We are very, very close to totality. I think I just heard the shout saying 1 minute. Now, we were hoping to bring you some live images of this, but you can see it in the background. Because of the dust storm, we had to drag all of our equipment in, and people were hanging onto tents and all over the place. It was amazing. It was one of the most exciting things most of us have been involved with. But now is the time, and I'm going to talk. Naturally, I started talking quietly because suddenly it's going dark. not a normal kind of dark. This is one of the most eerie. Wow. Totality is just seconds away.
It's there. 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 And it's gone.
Right, now, are they going to change the filter for us? Please.
We wait and... Oh!
There it
Oh,
goes. Whoa.
goodness.
There's totality, and it still looks wonderful through the clouds. It is spectacular. That's amazing. And there's the diamond ring. The diamond ring did bang! And the sun just came out in time for us to witness totality. I'm sorry. I'm emotional.